Our problem is to find the value of x in the given equation. It is the square root of x plus the square root of x plus the square root of x plus and so on. It means it is an infinite series, and it is equal to the square root of x times the square root of x times the square root of x and so on, still infinite product or infinite square root. With that, to start with, we try to simplify the right side by writing that as this one to be x raised to 1/2. This expression can be written as x raised to 1/4, followed by x raised to 1/8, which is multiplied by another 1/2, and so on. And now, note that this exponent can be added because they have the same base. We write this as x raised to 1/2 added by 1/4 plus 1/8 and so on. Note that this sum can be considered as geometric or infinite geometric progression with a common ratio of 1/2. Note that our formula for finding the sum of infinite geometric progression is first term divided by 1 minus r, where r is between the absolute value of r less than 1. And in this case, our common ratio is 1/2 by dividing 1/4 by 1/2 and 1/8 divided by 1/4. Therefore, we can sum up the exponent as using this formula, where the first term is 1/2 divided by 1 minus 1/2, and this gives us x raised to 1/2 divided by another 1/2, and the value of the right side is simply x. So on that sense, we can rewrite x plus square root of x plus the square root of x plus and so on equal to x. So in this case, we all know that the value of x is the square root of that infinite sum, in which case we can say that this particular value, referring to this, is still an x. So we can write this as x plus, this is also an x, equal to x. So squaring, we have 2x equal to x squared. And now we can solve for x by expressing this as x squared minus 2x equal to 0. This gives us x times x minus 2 equal to 0. And therefore, the values of x are 0 or 2. And that gives us our desirable values of x.